let's try this. Okay.
Okay.
Let's try this part together. It says how many
I
positive
started on
integers?
this one, but I'd like to start from scratch if that's okay.
Okay, so let me just read it quickly. Satisfy all of the following three conditions. N is divisible by this, n has at most 20 decimal digits. That is a string of consecutive 1 following by a string consecutive 0. So n is something like this. 1 and then 0, right?
Yes.
Okay. So can you tell me how many zeros do we need at least? Look, this number, pay attention. This number should be multiple of 20, right?
Yes, sir.
So how many, because it is multiple of 20, how many zeros? Because from third condition, it says we have some number of ones, then some number of zeros, right?
Yes, sir.
Okay,
Okay.
so number of
I
zeros
see.
is at least what?
Okay, I see.
Has to be at least what?
1 second. Let me just solve it really quickly.
Okay, sure.
500. Okay. 503.
At least how many zeros?
At least 503 zeros.
No. Why 503?
Let me just check again.
Let's call this number A. Do you agree it's, for example, some number of ones times, suppose, for example, it is A, we have B zeros, okay? So it is
Yes, sir.
A times 10 to the what?
Times 10 to the B.
Yeah, so this number is multiple of 20. Can be, if B is 0, then what's the problem?
No, it can't be because then because A cannot be a multiple of 2020.
Because it is odd, right? Then even divides odd, and that's not possible, right? Because 20 then divides 1 this one, and that's a contradiction. What about if B is 1?
It cannot be because in order to get it to the okay, hold on.
So then 20 divides some number of ones and then 1 0. What's the problem?
Okay, then 202 has to divide, so it can't be.
Exactly. 202 should divide some number of ones. This number is odd. This number is even. Again, we have problem.
Yes, sir. Okay.
But let's consider if B is at least 2. Do you agree then it's okay?
B is at least
For example, let's check B2. Then 220 divides some number of ones and then 2 zeros, right? So you can cancel this 0. And 202, you can divide it by 2. It's 101 divides this number of ones. So suppose we
Okay,
have
yes, that's
A1s.
possible.
A1s times 5, that's okay, right?
Yes, it's possible.
And if you have more zeros, again, it will be similar. It will be 200 again. 101 divides some number of ones times 5 times 10. And they agree this part has no effect on this divisibility because 5 times 10 is relatively prime to 101, right?
Yes, sir.
So in both of them, 101 should divide these number of ones. Again, 101 should divide these number of ones, right?
Yes, sir.
So do you agree that B can be at least 2 and it's not important? B is 2 or 3 or 4. All of them are same, right?
Yes.
And in all of them, we know that 101 should divide 1 some number of ones, right?
Yes. Yes.
Okay. So now let's write n is what? Is some number of ones, A1s, and some number of zeros, B, and we know B is at least 2. And it says n is divisible by 20. So the first condition turns to be what? 101 should divide number of ones, A1s. First condition. Second condition, it says it has at most 20. decimal digits. So a plus b is at most 2020, right?
Yes.
The third condition again is satisfied. We consider this form. So you should find a and b's that satisfy this.
Okay.
A1 should be multiple of 101 and a plus b is at least 2020, b is at least 2, and these things. Okay, and also we know a is at least 1.
Okay.
Okay, want to try the rest on your own or do
Yes.
you want to hint?
I'll try. I'll try. 1 second.
Okay, sure. Do you want to hint or want to?
No, sir. I'm trying to look for. No, I've reached the part where it has to also be divisible by 11. I'm just trying to figure out how to
Uh-huh,
make it so that all the digits are one. I
uh-huh,
think I think I'm on a track. I'm not sure if it's correct, but I'll try
uh-huh.
some more.
Okay, okay, sure.
Okay, sir. So I figured out the pattern. I understand the pattern. It's going to be 1 1, then 1 1 0 0 1 1, then 1 1 0 0 1 1 0 0 1 1.
Let me check, let me check. We cannot have 1 again. We have some number of ones, then zeros. Understand?
Um,
You cannot have, for example, 1 1 0 0 0 then 1 1, because we shouldn't have 1 1 again. Okay? Here, zeros, we have only two parts, ones and zeros. Okay?
yes, sir.
Okay, so A can be what?
No, sir. No, 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 sir. I'm sorry. I meant that 101, right?
Yes.
101 times 11, 101 times 1 1 0 0 1 1, 101 times
Okay,
one
okay. So
one
tell
zero
me,
zero
tell
one
me, A
one.
can be what numbers? A can be what numbers?
Okay. Uh, A can. Okay, 1 second, sir. Sorry. So A can be 1 1 1 1.
Means three. Three ones, right? Or
4 1,
four.
sir.
Four or three.
4 1, sir.
Four ones.
Yes, sir.
What's next, A?
And then next, it's going to be 8 ones.
8, 12 multiples of 4.
Yes, sir. That I got until 4 8 12. I haven't tested beyond 12, but it's 12.
Okay, so it seems exact. When we check a small example, it seems that multiples of 4 are correct, right?
Yes, sir.
So let's see how we can prove this. So some number of ones, do you agree is, for example, when we have A1s, it is A9s, or we can say what? Do you know how to calculate this without dot dot dot? Do you
Uh,
agree? It's 1 plus 10, right?
yes, sir. Yes, sir. I
Plus
understand.
10 squared all the way to what? 10 to the what?
10 to the A.
Pay attention.
A minus 1, sir.
Yes, because when we have three ones, it is 1 plus 10 squared, right?
Yes, sir.
When we have three ones. So 10 to the a minus 1. I told you how to calculate this. It is equal to what? First session, I think I told you that. How to calculate this.
Yes, yes, you did. 1 minus 10 to the A over 1 minus 10.
Exactly. If you simplify, it is what?
So 1 minus 10 to the A over 9, right?
Yeah, 10a minus 1 over 9, right?
Uh, yes.
Okay, and we know 101 should divide this, so should divide this, right?
Yes, sir. Okay.
So 101, because 9 has no effect, right? 9 and 101 are relatively prime. So then we can conclude when 101 divides this, then 101 divides what?
And to the A minus 1.
Yes, 10 to the a minus 1, because 9 has no effect on this, right? Because it is relatively prime with
Yes, sir.
101, right?
Yes, sir.
Okay, now we want to prove, so let's write it 101 divides 10 to the a minus 1. So 10 to the a is congruent to what mod what? 10 to the a is congruent to what mod what? If we change this to modular arithmetic.
is congruent to 0 mod 101.
Mod 101 is correct, but not 0. Is what?
Sorry, 1 mod 101.
Exactly, it's 1. So your claim is A can only be multiples of 4, right? 4, 8, 12, and
Yes,
so
sir.
on. So we want to prove it here. And now it is similar to
Oh,
many
okay.
problems that
We
we
can
solved
use
before.
we can use little Fermat's theorem, right?
Little Fermat's theorem you can use, but it is 10 to the 100, right? But because it is 4, 8, you can solve with the strategies that we used before Little Fermat's theorem, right? So try to check your claim that A should be only multiples of 4 or not. Okay, check it.
Okay. Oh, sorry, sir. It cannot be multiples of 4, but rather it has to be. Okay, okay, hold on. It's not that simple, but it is
Okay.
going to be
So you can change your
5.
claim. Try
Okay,
to find all
5,
numbers
9,
that work.
13.
5 you said the first is the first one.
Yes, sir. 5. Okay,
Okay, so let me check the first one. 10 is not good. 100 is congruent to what mod 101?
-1.
Exactly. 10 is 10, 100 is -1, so 1000 is what?
1000 is uh, -10.
Yes, you can multiply previous one by that. Then 4 zeros is what?
4 zeros is 100, which is okay. So it's 1.
Yes, -100. This one multiplied
Yes,
by 10 or -1 squared. So it's
which is
1.
+1.
So
Yes, sir.
A4 is the first one that is good, right?
A5, sir, right?
A4.
Oh, A4, my
4
mistake. A4.
zeros, right? A4.
Yes, sir.
So 10 to the 5 is what then?
10 to the 5, okay, is going to -1.
No. Is what? This one was 10 to the 4. 10 to the
Okay,
5th is
10.
10. So we have this period. 10 to the 6th is what?
10 to the 6 -1.
Exactly. So the period is this 10, -1, -10, 1, right?
Yes, sir.
And again 10. So we proved that multiples of 4 work, right? So
Yes, sir.
A should be 4, 8, 12. Okay, so we've simplified this. So let's consider how many it says good ends are there. So we found A should be 4, 8, 12, and so on. B should be at least 2, and A plus B should be at most 20, 20. So you should see how many good numbers are there, how many good ends are there, right?
Yes, sir.
For example, one good n is 4 ones, 2 zeros. One good n is 4 ones, 3 zeros, right? One good n
Yes,
is
sir.
8 ones, 2 zeros. All these numbers. Calculate how many good numbers are there.
Total is so the total number is 1,018,080.
Ah, you had careless mistakes. So can you explain your solution?
Okay. So when the okay, so it goes 4, 8, 12, right? So when it's 4, it has to be B is 2020. Or B can be up to, sorry, 2016, right?
Yes, at most 2016 and at least what?
And at least, oh, okay, at least, right, at least 4.
At least 2.
Sure, at least 2.
Yes.
Okay, I see. So it's always going to be at least 2. So I
Yes. So
have
how many good cases do we have here?
2014 then.
No. 20.
15.
Exact. Like this, you should
Okay,
check
okay.
the rest. Try.
Okay. 2015, then the next one will then be 2011,
Yes,
then
A8.
2009.
So is 2, B at most 2012, so 2011. The next one is what?
2009.
2007.
2007.
Okay. Next one is what?
Next one, 2003. Then
All the way to
1999.
maximum A is what?
Maximum A is 2016.
Then B is at least what, at most what?
B is at least 2, at most 4.
So how many cases?
To 3 cases.
So you should calculate 3. The previous
So,
case for A is what?
2018. So 2018 times 504.
Okay, so here for some of the, okay, so calculate the answer now. Last answer.
Let me just by hand, right, sir? We can't use calculators, right, sir?
You cannot use calculate.
Okay. 1017072.
Okay, so let's check. Here 3, 4. Okay, so look, when we have these, it is elements, some of the elements of an arithmetic sequence, right?
Sorry, I forgot to divide by 2. Divide by 2 gives us 508,536.
Yes, good job. Look, for these problems, you should say first one plus last one times number of elements. For number of elements, you say last one minus first one over common difference plus 1. You know these formulas?
Yes, sir, I know this one.
Okay, over 2. Now, if we calculate these, let's figure out the answer is what?
I just
Simplify
did. So
this.
it's
2018 over 2 is what?
508,536.
1009, right?
Yes, sir.
2012 over 4, which will be what? Which will be 503 plus 1, 4, right?
Yes, sir.
Okay, 504 times 1009. 4 times 9, 36, 304, right? Then
Yes, sir.
5 times 9, 45. So 0, 5. 635,805. So the answer is 508,536. Okay?
Okay.